This video is about one of my favorite tools for analyzing a data set and exploring a data set that you haven't seen before and mostly consists of a whole bunch of columns of numerical data. What you can see up on the screen is one of these sort of mystery data sets. There's lots and lots of numbers in it. What we know is we know that each row corresponds to an observation and each column corresponds to an attribute. There are lots of columns. If there are only two of them, maybe you could do a scatter plot. That might be convenient, but if you've got many columns, as we do here, it's kind of hard to tell what's going on. It doesn't really fit in your brain very well. There are many, many tools that help explore this, but my favorite is principal components analysis. It's easy. When it works well, and when it doesn't work, it's pretty obvious that it doesn't work. And it's pretty quick to do. R knows how to do principal components analysis for you, and can make short work of this task. So let's dive right in. I'm going to show you principal components analysis for not this data set, that's the second video in this series, but rather for a data set that we know what to expect, so that you can kind of see what it's up to. Okay, so let's get started. For this particular exercise, we just need the tidyverse library, mostly just for plotting, because actually principal components analysis is a base R function. All right, so let's start by just putting out a bunch of points that lie on a circle. We know what a circle looks like, and if I make a table or a tibble that's got a bunch of points reading out in radians, 0 to 2 pi, I can then add the x and y coordinates. The x coordinate should be the cosine, and the y coordinate can be the sine, or the other way around. Doesn't much matter. Okay, so these are points that lie on a circle. It's easy enough to check that this really worked. By just dumping this into a plot, like so. Yep, those look like points on a circle. Incidentally, you might say, well, let me try to connect them with a line, right? Geom line sounds like, geom line sounds like the right thing to do. However, notice geom line sorts by x, so this isn't exactly the right thing you want. You want actually a geom path. Okay, there we go. Looks pretty good. It's a nice circle. The end of it is not closed up perfectly. We could fix that if we cared. I don't care so much. Okay, so that's all pretty reasonable. But what if I had a lot more coordinates in my circle? So let's go ahead and make something like that. All right, so there's my t coordinates. Let's make a whole bunch of other coordinates. And I'm just going to kind of randomly put these guys in kind of willy-nilly. They're basically just a whole bunch of trig functions that I'm just throwing in there just for fun. Okay, and let's get rid of the T column because the T column really explains what's going on. So I'm going to deselect it. So rather than doing select T, I'm going to select minus T, which says get rid of it. Okay, let's take a look at this tab 2. And this is just a whole bunch of random trig functions stuck together. It's a look at it. It looks like it's 6-dimensional. That's kind of hard to visualize. Certainly you could try to go ahead and plot. You could try to plot some of these coordinates against each other, like x2 versus y2, for instance. And if I were to, plot this, did I miss x2? AES. There we go. You get some fun shape like this. These kind of shapes are kind of attractive. They're artistically kind of nice. All of these guys are called Lisa-Jew figures. A circle is a kind of Lisa-Jew figure, but as are various others. And you can see, taking different spins of these different directions, you get different Lisa-Jew figures. All right, now, if you're faced with one of these things, you might say, well, what is this? Well, it's some funny, twisty-turny thing. Well, under the hood, though, principal components analysis is going to help us get a better view on what's going on. In particular, what I had kind of picked up for you a moment ago, not this guy, but rather this guy, and looks pretty circle-like. In fact, it basically is a circle that lives in 6-dimensional space. Kind of hard to visualize. Pca can help squash this down. So in order to run Pca, we need somewhere to take the results. And there are 2 Pca functions available in R. There's prcomp, which I prefer because it uses singular value decomposition. There's also princomp that uses eigenvalue decomposition. You'll find people who prefer one or the other. My preference is for the singular value decomposition one. I find it a little bit more flexible and a little more noise robust, but you probably really won't notice much of a difference. Okay, in any case, it's a base R function. It just runs, and it spits out a new object, a Pca object. That Pca object's got a bunch of stuff in it. It's got some standard deviations, it's got some rotations, and other sorts of useful things. The thing we need, for the most part, is we need the x's. The x's are the new x values. The new x values come into a table that's got columns listed by PC1, 2, 3, 4. These are the principal components. And the idea is that if you only can plot a few things, plot the first few of them. So let's take that x guy. Let us coerce it into a tibble. And let's just plot the first 2 principal components. And indeed, it looks kind of circular. It's not quite a circle. It's a little more oblong than a circle. But basically what this is saying the majority of the data look pretty circle-like. All the other guys are a little less so. One thing that's helpful is to understand whether this is reliable or not. And for that, you need something called a Scree Plot. The Scree Plot is just simply the plot of the variances or the standard deviations. And it is convenient to, the way that these guys come in, these standard deviations come in like a list here. It's convenient to stack on a listing of principal component names. So the first one's the first principal component. So let's mutate that to add that row number, and we can go ahead and plot it. And this is our Scree Plot. And you can see there are 2 big standard deviations for the first 2 principal components. That means most of the variability that's present in the original data, this big table of numbers here, most of that variation is confined to the first 2 principal components. So if you see a Scree Plot, it's always decreasing like this, or not necessarily monotonically. It can kind of step down. But the number of big bars, first few big bars, are the proper dimension that your data wants to be. In this case, it's 2-dimensional, and hey, that's what we got. That's why the 2-dimensional circles seem to work. Of course, you can do lots and lots more with principal components analysis, so this is just a start, but it's a pretty good start. And you can use this to analyze lots of tables of numerical data. Enjoy!